In lesson 43, we got a little review or initial start into sine, cosine, and tangent. Here we're actually going to solve for right triangles using sine, cosine, and tangent. So in example 44.1, it says solve for the missing part. So we have h and b. Make sure that's clear. H and y, hb and y. So in order to solve, first thing is it's a right triangle. Because it's a right triangle, therefore we can use sine, cosine, and tangent. However, is there anything in this problem, or any of these letters, h, b, or y, that we could solve for first, just because of something we already know? Well, we already have a 24 degrees for this angle, and a 90 degrees, since it's a right triangle, for this angle. So therefore, we can find b by simply doing the triangle sum theorem. 90 plus 24 plus angle b equals 180. 90 and 24 would be 114 plus angle b equals 180. Subtract 114. You get 66 for angle b. And these two angles are also complementary as well. So that would be, yeah, if you have two sides, you could, and the right triangle, you could solve using Pythagorean theorem. But if you have two angles, you could solve using triangle sum theorem. So now we just got to solve for h and y. Now how we do this, let's go back to what we learned last lesson. So, toa. Okay? The sine goes opposite over hypotenuse, sine of theta. There's a cosine of theta equals a for adjacent over h for hypotenuse. And then we have tangent of theta, and that equals opposite over adjacent. So now we need to solve for h and y. So what is our theta? Let's go ahead and use 24 as our starting point. So what is the sine of theta? Okay, our theta is 24. So if we said sine of 24 degrees, what does that equal? Well, it equals opposite over hypotenuse. So what's the opposite of 24? Opposite of 24 would be y. Now what's the hypotenuse? Hypotenuse is h. So sine of 24 equals y over h. Well, that's two variables in y and h, so we can't solve for that. So we're not going to use sine. Let's look at cosine. Cosine of 24 equals adjacent. What's adjacent? 9.5. 9.5 over hypotenuse h. So now we have one variable and can solve. Here's how we would solve. We're trying to get h by itself. So right now it's in a denominator, so I'm going to multiply by h to cross out there and get h cosine 24 equals 9.5. Now cosine 24 is its own identity. So I'm going to put it in parentheses. So right now it's like saying h times cosine of 24. So we can do the opposite of multiplication and divide by cosine of 24. Now we put 9.5. Now we put that in our calculator with saying 9.5 divided by cosine 24 in parentheses, and then it shows that that side length would be 10.4 estimated. 10.4 is y, or h, sorry. And that makes sense. Our hypotenuse is longer than that side, so that's good. And now we've just got our last side. You can solve for y now by doing Pythagorean theorem if you wanted to. But I'm going to go ahead and use tangent here. Tangent of 24 degrees equals opposite y over adjacent 9.5. And I think this way is easier to solve because you just multiply by 9.5. And you have 9.5 times tangent 24. You put that in your calculator. And get 4.2. And there would be all three of your answers. And that's how you solve for right triangles. I put example 44.2 there. I'm not going to do that one. It's the same thing as what we just did. So you can solve that one on your own. But I do want us to look at example 44.3 because this one's different. The last one gave us, okay, we got to solve for A, B, and X. The last one gave us two angles that we knew. This one gives us two sides that we know. So this one's going to be different. Like I said in the past one, if we know two sides, we can automatically know the third by doing Pythag. So I'm going to go ahead and do that. 6 squared plus x squared equals 7 squared, since 7's our hypotenuse. 36. I'm going to solve for this pretty quick. 13 equals x squared, so therefore square root of 13 equals x. I'm going to leave it at that. Square root of 13 equals x. Now we got to solve for A and B. We only got the 90 degrees. How do we do that? Well, we're going to use what's called inverse sine, inverse cosine, inverse tangent. I'm going to go ahead and write this part here again. And let's say we're trying to find angle A. So we're trying to find angle A. So if I said sine of A, what would that equal? What is the opposite over hypotenuse? Well, opposite is radical 13. Hypotenuse is 7. Okay, let's look at the cosine of A. Cosine of A would be adjacent 6 over hypotenuse 7. Tangent of A would be opposite radical 13 over adjacent 6. Any of these you could use because there's only one variable. The only variable is A. I'm going to go ahead and use this one though because 6 over 7 is better than using radical 13s in my mind. So now from here, how do you solve? Well, all you do in this, once you have to this point, I'll show you in the calculator. What we can do is second cosine 6 divided by 7, close parentheses. Second cosine, once again, is inverse sine, cosine. And that gives us 31 point all that. So 31 would be, or 31 degrees would be A. But key being, when you're finding an angle, you have to use inverse. When you find a side, you don't have to. But when you get something like this, that's when you use inverse cosine. And now you can solve for B by doing triangle sum theorem. Or you could say, trigonometry, you could say sine of B equals opposite 6 over 7. And then type that in your calculator. Inverse sine 6 divided by 7 equals 58.9, so that'd be 59 degrees. Notice those would add up to be 90, plus the other 90 would be 180, and that'd be the triangle sum theorem. But you could just subtract the difference of these from 90 or 180 if you were doing all of them to figure out B. But any of those ways work. But that is solving for right triangles using trigonometry.